Alright, so exponential functions, both derivatives and the actual integrals of them. Here's all the work that we need. Okay, so the derivative of e to the x is just e to the x. Now, you might have to use change rule when something is the exponent. In other words, if it's like e to the 5x squared minus 4. You know, something like that. And that entire thing is in the actual parentheses. Okay, so in other words, that entire thing's in the exponent. Okay, now the derivative of something other than a, which would be something other than e to the x, is a to the x times the natural log of that number. Okay, now the best way to explain how to do that is to actually how to do the derivative of it. Okay, so first off, the integral of e to the x dx is going to be e to the x plus c. That one's pretty simple and straightforward. Now this one is actually really cool. If you do the integral of some other number than e to the x power dx, you get that number to the x power divided by the natural log of that number plus c. Okay, and that's actually done by substitution by parts. And the actual method is that whatever the number is, so let's say it's a, you would set it up as a equals e to the natural log of a. You would set it up as that, and then you would actually do the substitution of parts like that, because it is actually infinitely more easier to actually do this integral than it is to do this, and it actually does make all kinds of sense in the world. I love how this stuff works. Okay, but this is going to be the key to actually working with it, which is actually going to be substitution by, well, not substitution by parts, but u substitution with replacing a with e to the natural log of a, and then once you start working it out, it actually makes all kinds of sense. Alright, so just making up a problem like this, 3 to the x dx. Okay, now I could go ahead and cheat and just use the rule and just say, oh, it's just that. But what I'm going to do is I'm going to show you how it works. Okay, so 3 equals e to the natural log of 3. Okay. Alright, now since we also have the x in there, so if I raise this to the x power, I have to raise this side to the x power as well. So this is going to become x times the natural log of 3. Okay, so now what I'm dealing with is Alt 244, Alt 245, e to the x times the natural log of 3 dx. Okay, so I'm raising that. Now what I am going to do is I'm going to use substitution, or u substitution, and u is going to be equal to x times the natural log of 3. Okay, so when I do du dx, and I do my u substitution, this is going to become just the natural log of 3. And then I multiply both sides by dx, and du becomes the natural log of 3 times dx. Okay, now if you notice, I have no natural log of 3 in the base area. All I have is this so far. 244, 245, e to the u dx. I mean, literally, this is all I have so far. Okay, so what I'm going to do is I'm going to have the constant out here be the natural log of 3 divided by the natural log of 3. Okay. Alright, and what I'm going to do is I'm going to bring this natural log in here because I need to match up this natural log of 3 and dx with this one so that I can replace it with du. Okay, and so what I'm left with is this right here. E to the u du. And I do my derivative and I get e to the u plus c. Okay, now if you remember, e is going to be replaced with something, so I can just go ahead and replace it, and so I get e to the x times the natural log of 3 plus c. And if you remember, I started out with the 3 to the x right there. Well, I've already defined this e to the x times the natural log of 3 as 3 to the x, so I can just go ahead and replace that one right there. Oh, and you know what I totally forgot? I just totally forgot that I had my constant. So let's move everything over and shift it over a little bit. So my constant in front, I forgot it. I knew something was up. Natural log of 3. Okay. Right, so I had this right here, and so I should have this over here. So this should be all divided by the natural log of 3. There we go. Okay, and so this actually turns into 3 to the x divided by the natural log of 3 plus c, and that's the actual proof of it. And it's actually kind of cool how it works. So what you do is you temporarily replace 3 to the x with e to the natural log of 3, and then you start working with your stuff all around it. And by using U substitution, you can actually just see how exponentials, integration of exponentials, are just like kind of just a little placeholder for exponentials, or for e at least, the number e. Okay, and that's it for exponential functions and their derivatives and integrals. I'll talk to you guys later. Bye.